it's going to give us a 9. And then we're going to have 2's down here. So which means this is a quadratic pattern. Okay, so if that is true, which means for me to get my next term, I'll have to plus 11. Okay, that gives me 38, and then I'll have to plus 13, and then that will be a 51. Okay, so T6 is 38, okay, and then T7 becomes 51. All right, so that is 1.1. Then 1.2, they want us to find the general term P of the sequence. So we know that the general term of a quadratic is always given in the form of an squared plus bn plus c. Okay, what we need to determine will be the a, the b, as well as the c. All right, so I'll just put the sequence this side. So it's 3, 6. Okay, 3. We have 6. We have 11. We say that will be a 3. That will be a 5. And then this is a 2. Our second difference is a 2. So he said we're going to equate that to a. Equate the 3 to 3a plus b. And then equate this 3 to a plus b plus c. All right, let me start with the bottom part. So 2a is equal to 2. Divide both sides by 2, which means a is 1. Then 3a plus b is equal to 3. If our a is a 1, if we substitute a with a 1, that will be 3 times 1 plus b is equal to 3. So this 3 will cancel the 3 out, so which means the b is a 0. Then if we have a plus b plus c is equal to 3, remember our focus is the first term, the a plus b plus c. The 3a plus b should be the first term of the first differences. So a is 1, b is a 0, and then we're looking for c. So c is going to be a 2. That's 3 minus 1, which is a 2. Then for us to get the tn, which is the nth term, it's just going to be n squared plus 2, since the b is a 0. Okay, so that is 1.2. Then they want, but before we even do the conclusion, they told us they want the p. Okay, so instead of tn, let's use tp, which is going to be p squared plus 2. This is the most accurate one. Okay, then use the formula to calculate p if the pth term is 627. So where there is tp, we're going to replace it with a 627, and then we find what p is. Okay, so this is 1.3. So we're saying 1.3. We're saying 627 is equal to p squared, okay, plus 2. Then I can move the 2 that side, so that I have 627 minus 2 is equal to p squared. That becomes 625 is equal to p squared. Then I can find the square root, okay? So square root of 625 should be a 25. Ne? Yes, it's a plus or minus 25. But looking at the pattern and how it was increasing, I mean, it's just a growing, it's positive. We cannot expect to have any negative numbers that side. So I'll just draw a conclusion and say that therefore my p is a 25. Okay, p becomes a 25. So that is the position where the term is 627. Okay, then question number 2. With whatever you have attempted, let's compare. Telling us if we are given a geometric, okay, they're being specific here. They want us to determine the nth term of the series. Nth term of the series, okay. So we know that the nth term of the geometric is always a(r) to the exponent of n minus 1, where a is the first term, r is the common ratio. So what we're going to do, we need to determine our r, okay? So for me to get r, I'll get my t2 divided by t1. So that is 4x cubed divided by 8x squared. Okay, when I simplify that, I only end up with x over 2. Okay, so this is my common ratio. So to answer the question 2.1, our Tn is going to be our first term, which is 8x squared. Okay, the common ratio is x over 2 to the exponent of n minus 1. That's how we can express it. Okay, then 2.2, they're asking us that for which value or values of x will the series converge. So we know that the condition for convergence is that our r must be between -1 and a +1. Okay, so we shall write down this condition first and then substitute r with our x over 2. Okay, so it's a -1 into x over 2 is less than 1. And then we need to just get rid of whatever is around the x and leave the x within the middle section. Okay, so I'll multiply through by 2. So times 2, and then times 2. These 2 cancels. That's all. I'll have -2 is less x is less 2. So these will be the values for which the series will converge. And then 2.3, they want us to calculate the sum of the series to infinity if x is 3 over 2. Okay, so that is going to change the whole scenario. Okay, let me just put it here. So they're telling us x is 3 over 2. So which means I need to recalculate my terms, okay? So which means our first term is going to be 8 into 3 over 2 squared, okay? 8 into 3 over 2 squared, what does it give us? It gives us 18, okay? That's the first term. And then the second term will be 4 into 3 over 2 cubed. We're saying 4. Let's see what we have. 4 into 3 over 2 cubed. I'm having 13,5, which is the same as 27 over 2. Okay, it's not a big deal for as long as I have my first term. With the common ratio, I can still use my our x over 2, which will be 3 over 2, and then divide by 2, which becomes a 3 over 4, okay? Alternatively, if you use the 2 terms that we have here, 27 over 2, you divide it by 18, you should be able to get the same thing, the 3 over 4, as your common ratio. Okay, so we go down and say that the formula for sum to infinity is given as a over 1 minus r. So our first term, which is a, is 18 over 1 minus the 3/4. Okay, so let's just punch this in the calculator, or we can simplify further if you want, okay? So 18 over 0,25. Okay, so this gives me 72. So which means our sum to infinity becomes 72. All right, so that is question number 2. All right, let's go to the next question, which is question number 3 and 4. Feel free to pause a bit, attempt the question before we can compare the solutions. Okay, so question number 3, they're telling us consider the following sequence. We have 399, 360, 323, 288, 255, 224. And then they want us to determine the nth term, okay? So for questions like this, where they don't tell us whether it's arithmetic, geometric, or quadratic, it's upon you to investigate, okay? You can investigate by trying to get the common differences or the common ratios, okay? And see. So due to this side, we have 399 and 360. This is question number 3. So 399, we have 360, then we have 323. Okay, and then we have 288. I think I'll stop there since I'm not finding any terms afterwards. Okay, so I'll say 360, I'll subtracting 399. That gives me a -39. Okay, let's see 323. We're subtracting 360, getting a negative 37. And then 288, we subtract 323. We say 288, we're subtracting 323, which is a negative 35, okay? And then when we plus a 2, we shall get our quadratic. Perfect. Okay, so with a quadratic, remember, the second difference must be equated to A. The first term of the first difference must be equated to 3A plus B, and then the first term should be A plus B plus C. All right, so let's see. So if I have my 2A is equal to 2, divide through by 2, A is a 1. Then my 3A plus B is equal to negative 39, okay? So if our A is a 1, that's gonna be 3 times 1 plus a B is equal to negative 39. Let's move the 3 that side. So it's gonna be negative 39 minus a 3, okay? Which must give us something like a negative 42. And then our A plus B plus C should be equated to 399, okay? A is 1, the B is negative 42 plus C should be 399. All right, so that's negative 41, which will add that side, 399 plus 41, which should give me 440. Okay, so I have my A, I have my B, and then I have my C. So we know that Tn is in the form of an squared plus Bn plus C. Our A is 1, so it's just n squared. Our B is negative 42, so minus 42n. The C is positive 440. All right, so that is that for 6 marks. Okay, let's move on. Then 3.2. Determine which term or terms will have a value of 0. So when they ask which terms, this 0 is our Tn. We need to find what n is, okay? So we're just gonna use the same formula that we just obtained, okay? And then do the right thing. So this is 3.2. So where there's Tn, I can put a 0, okay? So it's n squared minus 42n plus 440 is equal to 0. Then from this point, what I can do, I can use the quadratic formula. Alternatively, I can also use the factors, okay, depending on which one you prefer. So if I use my factors, okay, I'll have n and n. So 440 and 420, it could be 20 and 22. So if I have negative 20 and negative 22, if I multiply the 2, we'll get a positive 440. Then if I plus the 2, I'll get a negative 42. Okay, so in this case, we need to just solve. So n is a 20 or n must be a 22. Now, since both values are positive, both values do qualify to be our answers, okay? Had it been that one was negative, we can never have a negative position. So in this case, we're gonna take the 2 answers. Why are we taking the 2 answers? We know that the quadratic pattern is more like a parabola. And with a parabola, it is very possible to have the same output with different input values, okay? So that is what we are referring to. So remember, equal to 0 simply means you're looking for the x-intercept or the roots. All right, so that is 3.2. Then 3.3, which term in the sequence will have the lowest value? Now, we just say that this is a parabola, okay? Then for the lowest value, they're asking us for the axis of symmetry of this, okay? Whether it is lowest or largest, it depends, okay? So in this case, our A was greater than 0. That's why it has the lowest or the minimum. Had it been that the A was negative or less than 0, then our parabola or quadratic function would have a maximum value. So from our functions, we know that x is negative b, over 2a. So whatever we get here, that is the answer that they want. So we know that our b was negative 42, okay? So that's gonna be negative and negative 42 over 2, our a was a 1. So negative, negative, that's gonna be a positive. So 42 over 2, which will be term number 21, will be the lowest. Okay, we're looking just for the position. All right, so that is question number 3. Okay, let's see. With this proof, it's always in your textbooks, within your books. There's even a video that we did as to how we can prove this. Okay, so AR squared. So we know that this is basically the sum of the geometric. Okay, we can still go through it and see. Question number 4. This is question number 4. So 4.1. Now to prove the sum of the geometric, all we can say is that the sum should be equivalent to the series, which is A, the first term. The second term is AR, the third term is AR squared, and then the story continues, okay? I can have my second last term, which is AR to the n minus 2, and then my last term, which is AR n minus 1, okay? Then we need to multiply, okay, if we call this equation 1, we need to multiply this first equation by R, okay? So on the left, we shall have R times Sn, which is Rsn. Then this will be AR, and then this becomes AR squared. This becomes AR cubed, and so on and so forth. Then if I multiply by R, I'll have AR to the n minus 1, and then the last term will be just left with AR to the n. So this is my equation number 2. But when I look at the format, okay, with the format, they're telling us that R must be greater than 1. So we are subtracting R minus 1. So what I'm going to do, I'm going to say equation number 2. Okay, equation number 2 minus equation number 1. So I'll have my Rsn minus Sn is equivalent to, when I subtract this, I'll be focusing on what we call the like terms, okay? So we know that this is gonna cancel that, this is gonna cancel that, the AR3 will also cancel with the next one, and so on. This will also cancel with that, this will cancel with whatever is meant to appear here. So in other words, I'll be just left with this as well as this. Okay, so since equation 2 is coming first, then I'll have AR to the n minus a. Then the next step is just for it to factorize. So let's take out the Sn on the left-hand side. I'll have R minus 1. Or on the right, we shall just take out the A, which we shall be left with R to the n minus 1. Then just isolate the Sn, make Sn the subject. So divide both sides by R minus 1, then over R minus 1. And then if that is done, we are done proving. So there we can qualify for the, how many marks? It was 4 marks, yeah. So that's how we prove that. Then 4.2, if we are given the geometric of 3 plus 1 plus a third and so on, they want us to get the sum to infinity. So what should guide you is the formula. We know that sum to infinity is given as a over 1 minus r. We know that a is the first term, which we already have, okay? And then r is the common ratio that we can get. So let's get the r, okay? So t2 over t1, which is 1 over 3, which is a third. Okay, let's substitute. So 3 over 1 minus a third. Just punch this into your calculator. Okay, so that is it's 9 over 2. That's what I'm getting, or 4,5. Okay, 4,5 or 9 over 2. So that becomes the sum to infinity. All right. Then question number 5. Given the sequence, we have 4, we have x, we have 32. They want us to get the values of x if the sequence is arithmetic, if the sequence is geometric. So what they are testing is basically the knowledge that you know what happens when the sequence is arithmetic. Yes, we do, because we know that there's just gonna be a common difference across the terms, okay? And then for geometric, there has to be a common ratio. All right, so let's see. So what we can say for question 5, yes, it's 5.1. Okay, 5.1, so the terms are basically 4x and 32. So 4x and 32. 5.1.1, so for as long as it is arithmetic, I'll need to get the difference here, which is x minus 4. And then the difference here will be 32 minus x. So these differences have to be exactly the same. So I'm going to equate the two. So x minus 4 is equivalent to 32 minus x. Then all I'll do is transpose and collect the like terms. So if I move the x that side, move the 4 that side, I'll have 2x is equal to 36. And then our x becomes 18. Okay, so that is 5.1.1. And then 5.1.2, we said 4x and 32. Okay, 4x and 32, we're just gonna get the ratios, okay? That T2 over T1 should be equivalent to T3 over T2. So that's going to be x over 4 is equivalent to 32 over x. And then let's do the cross multiplication. So x and x, we shall get x squared. And then 32 multiplied by 4, I'm ending up with 128. Okay. Then from this, I can find the square root. Okay. So what is the square root of 128? I'm getting 8 root 2. So which means x is gonna be plus or minus 8 root 2. Okay. We prefer it as a side, okay? Now it all depends. You can keep it as a plus or you can keep it as a minus, depending on what the question was talking about. So you cannot conclusively go ahead and decide whether it's a positive or negative because we don't have anything extra here. Had it been that we had another term here, then we'll be able to tell. But for now, I'll leave the two answers just like that because the square root of any number will always give us a positive or negative. All right, 5.2. 5.2. Determine the value of P if P is the sigma notation from K1 up to 13, 3 to the K minus 5. All right, so we have sigma notation from K is equal to 1. Is it up to 13? Perfect. Then we have 3, K minus 5. Okay, so for this case, what we need to do, they want us to get the sum, okay? But we don't know whether it's arithmetic or geometric. You can take a guess and then see, but we need to be sure on what we're dealing with. So step number 1, just substitute, okay? Substitute K starting from 1. You go to 2, you go to 3. You don't need to substitute everything, okay? If it's just countable numbers that are very few, you can substitute all of them and then use your calculator to add them directly, okay? So with the first one, if K is a 1, we're gonna have something like 1 over 81. That's gonna be our first term, okay? And then if K is a 2, okay, I'm gonna have 1 over 27. And then if K is a 3, then we're gonna have 1 over 9. So by just the look of things, we can see that this is a geometric sequence, okay? Now, if it's a geometric, we know that the sum of a geometric is given as A into 1 minus R to the N or 1 minus R. Alternatively, the other formula that we just proved, okay? Then we have our A. We can get the R, okay? Let's have 1 over 27 Okay, we are dividing it by 1 over 81. It should give us just the whole number, which is 3. Okay, so our R is a 3. And then we need to find out how many terms do we have. Okay, so for the number of terms, get the upper limit, which is 13, minus the lower limit, which is 1, and then plus 1. So which means we're talking about 13 terms. So I'll just substitute. So S13, which will be the same as P, should be equal to 1 over 81 into 1 minus my R is a 3, the exponent of 13, close the bracket, over 1 minus 3. Okay, so there's no harm in using this formula or the other one. For as long as the substitutions are done correctly, you should be able to arrive at just the same answers. Okay, so we have it's saying 1 minus 3 to the 13, just punching this in the calculator, over -2, -2. Okay, so the answer I'm getting is 797,161 over 81. So this is what I'm getting. Alternatively, you can give it as a decimal, which is 9841,49, if we round off to decimals. All right, so that is how we would approach that question. Then 5.3, they want us to prove that for any arithmetic sequence with the first term of A and the constant difference of D, the sum will be given as that. Okay, let's see. 5.3. 5.3. So we know that the first term of an arithmetic is given as A. And then the second term will be given as A plus D. The third term will be A plus 2D, and so on and so forth, okay? I'll have, let's say, the third last term. Okay, so let me take, we know that the last term is given as Tn, which is A plus n minus 1 into D, okay? So if I let this whole thing be equal to L, then my third last term will be L minus 2D. My second last term will be just L minus D, okay? And then my last term will be just L. So if I add everything, I'll just say Sn, okay? Then the second step that I have to do is switch this thing around, okay? It's the same equation, but swap it around. What came last should come first here, okay? What came second last must be second here. This is L minus D. And then I'll have L minus 2D, and then whatever is in between. Then I'll have my A plus 2D. I'll have my A plus D, and then I'll have my A. All right, then after that, we shall add the 2. Remember, for geometric, we subtract, ne? For arithmetic, we plus. So Sn and Sn, I'll have twice of the Sn's, okay? This and that, I'll have A plus L, okay? In this case, I'll still have A plus L, and then A plus L and A plus L up until the last time it will be just A plus L. Now, if we're talking about a certain number of terms, because this is a finite series now, certain number of terms may be n, okay? So we shall just get n multiplied by A plus L. This is equal to twice Sn. Divide both sides by 2, okay? So Sn will be just n over 2 into A plus L. But we say that L is basically A plus n minus 1 into D, which is the nth term. So just replace L with that. So A plus n minus 1 into D, then we shall have whatever the question was asking for. So n over 2 into, that's twice A plus n minus 1 into D. Please and please, this is not the only sort of approach to use. If you have a quicker, better approach, please use it. You'll still get your full marks. All right, so that is question 5.3. Then question 6 and 7. Feel free to pause, attempt the questions before we can proceed with the solutions. Okay, so question 6, they're telling us that there's a quadratic pattern. Okay, with a second term that is equal to 1, a third term that is equal to -6, and then a fifth term that's equal to -14. Calculate the second difference of this quadratic pattern. Okay, let's see. This is question number 6. Let's just analyze the question. Okay, we don't have a first term, okay, but our second term is a 1. That's fine. Our third term is a -6. Okay, we don't have a fourth term, but we have the fifth, which is -14. So that is all we have now. They want us to find the second difference. All right, so what we need to do, what we can do, if I have this as my x, let me call that my y. Okay, so what I know, my first term of first difference will be t2 minus t1, which is just 1 minus x. In this case, I'll have -6 minus 1, which gives me -7. In this case, I'll have y minus -6, which is just a y plus 6, and then -14 minus y. Okay, so let's see with the second differences. We know that -7 minus this, that's going to be -7 minus 1, which is -8. Now it's going to be a plus x. Okay. And then in this case, I'll have this whole thing minus that, which is going to be y plus just a 13. And then in this case, I'll have -14 minus 6, which is going to be -20 minus 2y. Okay, so this is the first difference. Okay, this is the second difference. But we know the second difference of a quadratic must be the same, must be equivalent to each other. So I can equate this and that because they are the same second differences, okay? So y plus 13 should be equal to -20 minus 2y. Let's transpose this to that side, which is going to be a 3y, and then I'll have -33. Divide through by 3, which means my y is -11. What was the question asking for? Calculate the second difference. So since y is -11, our second difference is just this whole thing, or that whole thing. So it's -11 plus 13, which is a 2. Okay, so that's what the question wanted. Then 6.2, hence calculate the first term. Okay, so remember we said our first term is x, né? We just let the first term to be x. So in other words, we just solving for x. So I can get this -8 plus x, and then I equate it to 2. Okay, so -8 plus x is equal to 2. Move the 8 that side, which means x is 10. So that is the first term. All right, so that is question number 6. Okay, so we have question number 7. Question number 7, pause, attempt, and then we go over it. Okay, 7.1. We have 3x plus 1, 2x, 3x minus 7 are the first 3 terms of an arithmetic sequence. They want us to get the value of x. So just like what we did above, let's get the differences and equate them. So the difference here is going to be 2x minus 3x. That's going to be -x. But we are subtracting 1. The difference here is 3x minus 2x. That's going to be x, but still with a -7. So this is our difference 2. This is our difference 1. And then we just have to equate the two. So negative x minus 1 is equal to x minus 7. Let's move the x that side. It is going to be negative 2x is equal to negative 6. Divide both sides by negative 2, which means my x is a 3. Okay. 7.2. The first and the second terms of an arithmetic are 10 and 6, respectively. They want us to calculate the 11th term. First term is 10. Okay. This is question number 7.2.1. Okay, so our A is a 10. And then our T2, they told us the 6. Ne? Okay, so which means that the common difference is 6 minus 10, which is a negative 4. Then they want us to get T11. So for us to get T11, just substitute into the nth term, okay, which is A plus n minus 1 into B. So to get T11, it's just going to be A plus 10D. Our A is a 10. That's a 10 multiplied by negative 4. Punch that into your calculator, which becomes negative 30. So that is the 11th term. Then 7.2.2, they want us to get the sum of the first n terms of this, no, the sum of the first n terms of the sequence is this. They want us to get the n. They want us to get the number of terms. Now, since we know that this is an arithmetic, we're going to use the sum of an arithmetic to work out this. So that sum is given as n over 2 into twice A plus n minus 1 into D. 6 marks. Let's see. So where there is Sn, we're going to use negative 560. We said our A is a 10. Our D is negative 4. All right, perfect. So 560, do we agree? Yes, perfect. Okay, let's substitute. I have n over 2 into 2 times 10 plus the n minus 1 into negative 4. Should be equated to negative 560. I can start by multiplying through by positive 2. Okay, so these two cancels that. I'll have n into, that's a 20, minus 4n plus 4 is equivalent to negative 560 times 2. That's giving me negative 1120. Okay. Then, okay, so we know that 20 plus 4 is going to give us a 24, but multiplied by n, so I'll have 24n. And then the n multiplied by negative 4n, that's going to be negative 4n squared is equal to negative 1120. So let me create a standard equation, okay? So that's going to be 4n squared minus 24n minus 1120 should be equated to 0. Okay, I'm just moving everything to one side. Then with this, I can choose to divide through by 4 so that I have n squared minus 6n minus 280 is equal to 0. Then what I need to do is factorize this, okay? Remember, we can use our quadratic formula. There is no problem with that, okay? So that you can get your answers straight away. And then if I choose to use my factors, okay, if I use my factors, that would be n and n. I can look at 14 and 20. Can make this a negative 20. Okay. So if I have n minus 20, n plus 14 should be equal to 0. So either n is a 20 or n is negative 14. What was the question asking for? The sum of the first n terms is negative 560. Calculate the value of n. So since we know that n is the number of terms, we can never have counting number of terms and we say we have negative 11 people. It's like missing in action, right? So this does not apply. So the number of terms can never be a decimal. It can never be a negative, okay? So which means our focus must be the n is equal to 20. Okay, so then question number 8. I think this should be the last one for this worksheet. Okay, so the following sequence of numbers forms what we call a quadratic. Okay. The first differences of the above also forms a sequence, which should be a linear or arithmetic. Determine an expression for the general term of the first differences. All right, so -3, -2. Okay, let me jot it down here. It's saying this is question 8. It's in terms of A and B. Okay, so -3, -2. Okay, and then we have -3, -6. And then we have -11. All right. Okay, so for us to get our first term, this is going to be -2 minus minus, which is going to give us a 1. And then in this case, we're going to have a -1. And then there, we're going to have a -3. And then in this case, we're going to have a -5. When we look at this, from 1 to negative, that's going to be -2, -2, -2. So they want us to get the nth term of this difference. Yeah. Okay, so this is going to be our common difference. So we know that the first difference should form an arithmetic. Okay, let's just use the formula for arithmetic, even though there are quicker ways of getting that general term. So our first term is 1, okay, plus n minus 1 into the common difference, which is a -2. Open that up and simplify. So it's going to be -2n plus 2 plus 1, which is a -2n plus a 3. So this is what the question is asking for. All right, then part B, calculate the first difference between 135th term and 136th term of the quadratic. All right. Now this is what we need to know, okay? We know that the first term of the first difference is between T1 and T2 of the quadratic. The second term of the first difference is between T2 and T3. The third term is between T3 and T4, okay? Now, for us to get the difference between 135 and 136, our first difference will be at 135, okay? So from the formula that we just obtained, we just need to calculate T135. All right, so T135 is going to be -2 times 135 plus a 3. Just punch that into your calculator. 135 plus a 3. And that gives me -267. We can see that this is a decreasing kind of pattern. It's becoming smaller and smaller and smaller. Okay, so that's the answer for B. Then let's look at C. C is asking us to determine the expression for the nth term of this quadratic. Okay. Nth term, we know that this should be equated to the 2a. 3a plus b is a 1. And then a plus b plus c should be -3. Okay, so we're saying 2a is -2. Divide through by 2, a is -1. Then 3a plus b should be equated to 1. And then if a is -1, that's going to be 3 times -1 plus a b is a 1. Move it that side, which means b is a 4. And then lastly, if a plus b plus c, this should be equated to the first term of the quadratic, which is a negative 3. Okay, so if that's a negative 3, that's negative 1 plus 4 plus c is negative 3. That's a 3, move it that side, which means c is going to be negative 6. So generally speaking, we can say that our nth term is negative n squared plus 4n minus 6. All right. And then lastly, buddy, explain why the sequence of numbers will never contain a positive term. Okay, so what we can see, remember we say the quadratic pattern is just more like a parabola, okay? So if I'm to look at this parabola of ours, it's just in that sort of format. If that is the kind of format, let's see, okay, the highest point that this parabola will reach, okay? We can get the position and get that position and then substitute it into here, okay? So this maximum value will give us a hint on whether we can have a positive or we can even have any just negatives, okay? So if I'm to get the turning point, which is negative b over 2a, our b is a 4, so negative 4 over 2 times negative 1. Okay, so we know that the turning point is going to be at a 2, where n is a 2, okay? So if n is a 2, let's substitute and determine the highest point. So that's going to be negative with the 2 squared plus 4 into 2 minus 6. That's a negative 4 plus 8 minus 6, which is a negative 10 plus 8, which is negative 2. Now, since we've just obtained the highest point or the maximum value, which is what? Negative 2. It simply means that the function can never go above the horizontal axis, okay? So we can say that since the highest value is negative 2, the graph or the pattern can never contain positive values. Remember, our terms are just the y values. Okay, so that is what I would have done with this particular worksheet. All right, so let's look at the second worksheet. Okay, so question 2. You can pause, attempt before we look at the solutions. All right, 2.1. Given the geometric series, 1 over 5 plus 1 over 15 plus 1 over 45 and so on, is this a convergent series? Justify your answer with calculations. Now, we know that for a series to be convergent, the common ratio must be between 1 and negative 1. So let's see. Let's determine the common ratio. So for us to get the common ratio, it's T2 over T1. So if we have 1 over 15 divided by 1 over 5, we shall get our common ratio as 1 over 3. Okay, now we know that 1 over 3 is bigger than negative 1, but it is smaller than positive 1. So is this a convergent series? Answer is going to be yes, because negative 1 is less than a third, and then it's less than 1. So that is how that would be answered. Then calculate the sum to infinity. So we know that sum to infinity will be given as a over 1 minus r. Let me just write it this side. This is worksheet 2. Okay, so sum to infinity is a over 1 minus r. So our a is 1 over 5 over 1 minus a third. All right, so let's just punch that into the calculator. over, we said 2/3. So that gives me a 3/10 as our answer. Or you can give it as a decimal, which is 0.3. Okay, and then 2.2. They're telling us that there's a combination, okay, of the geometric as well as the arithmetic. Okay, so then they want us to write down the next two terms of the pattern, okay? So if this is 1x, 2x's, 3x's, the next part will be 4x. This is 1/3, 1/9, 1/27. We shall have 1/81. It's like we're multiplying by a third. Okay, multiply through by a third. So these are our next two terms as per the question. Then 2.2.2. They want us to get the general term here for the odd terms of the pattern. Now we know that odd numbers are basically numbers that will give you a remainder. Okay, so which means we're looking at the x, 2x, 3x, and so on and so forth. So they want the nth term of the arithmetic. Okay, so we're going to have Tn is equal to, we put it aside, a plus n minus 1 into d. Okay, this is 2.2.2. So Tn, our first term is x plus n minus 1. What's the common difference? It's 2x. We have 3x. We have 4x. First one was x. So which means our common difference is just x. Okay, feel free to open it up. Okay, so x, nx minus x, which means the nth term is just nx. So n multiplied by x. If n is 1, then that is it, okay? Straightforward, which is nx. And then they want us to get the value of P26. Okay, so the question now is going to be, is 26 an odd number or it's an even number? So we know that it's going to be an even number. Okay. So if 26 is an even number, we're going to look at the even pattern. Okay. The even number pattern is 1/3, 1/9, 1/27. So if I look at that pattern, this is 2.2.3. So 1/3, 1/9, 1/27. Okay. So if I try to determine the nth term of this geometric, okay, we know that's going to be AR to the exponent of n minus 1. What's the R? We say the R was just 1/3. Then the question is not asking for T26. We're going to look for T13 of the even pattern, because the 13 will represent the odd numbers and then 13 will also represent the even numbers. So I need to find T13. Okay, let's just do the substitution. So T13 is going to be the A, which is 1/3. My R is also 1/3 to the exponent of 13 minus 1. So we just have to punch that into the calculator, which you can also, I don't want to speculate. Okay, let me punch it into the calculator straight away. Okay, I'm saying 1/3 to the exponent of 12. Okay, so I'm getting my answer as 1/1594,323 as my P26. Okay, so P26 is equal to this answer of ours. All right, then 2.2.4, if the sigma from n is equal to 1 up to n is 21 of Pn. Remember, this whole sequence or the combination part represents the Pn, okay? They want us to determine the value of x. Remember, sigma, whenever we see this symbol of sigma, it deals with the sum, okay? So since we have a combination of patterns, we need to first of all know how many patterns are we going to have on the even side, how many patterns or how many terms are we going to have on the odd side, okay? So the number of terms that I have is 21 minus 1 plus 1, which means I'm talking about 21 terms, okay? So if there are 21 terms, which means 11 of them are going to be even, and then 10 of them are going to be odd. So remember, the even ones and the odd ones. That's our main focus, okay? So let's see. Is our argument correct? Or it's the other way around? So we know that 1, 2, 3 is the odd. 1, 2, 3. No, not 1, 2, 3. It's 1, 3, 5, 7. 1, 3, 5, 7. That should give us the odd numbers. And then the even should be the 2, 4, 6, and so on, which means it's gonna be the other way around. So the number that started first, this one, is the odd. So the odd numbers are going to be more. So let's just correct that. And then the even numbers are going to be less since we're talking about 21. Okay, so which means that if I get the sum of the 11, the sum of the 10, I must equate them to 33,5. All right, let's see. So the odd numbers are the arithmetic now. And then the even numbers are the geometric. Okay, so I'll go down. This is 2.2.6 now, or 2.2.4. 2.2.4, so sum of arithmetic is n over 2 into 2a plus n minus 1 into d. Will this make sense? Yeah, it will make sense. It's fine. Or you can use the a plus l straight away. Now, we said arithmetic is the first one, which is 11 terms. So that's going to be 11 over 2 into 2 into the first term is x, plus we're talking about 11 terms, so 11 minus 1, which is going to be 10, multiplied by the common difference, which is x. All right, so I can simplify this further, because now this is 12x. Then 12 times 11, which is going to be 132. X over 2. So 132 divided by 2, which is going to be a 66x. Okay. Then let's look at the geometric. We know that the Sn is given as a into 1 minus r to the n over 1 minus r. So if the first term was a 1 over 3 into 1 minus, we have 1 over 3 to the exponent of 10 over 1 minus 1 over 3. Okay, let's just punch this directly because there are no unknowns here. So 1 over 3. Come on, my calculator, don't betray me, please. Okay, so 1 minus 1 over 3 to the 10, ne? Over, this is gonna be 2/3 now. Okay, what are we getting? we're getting 0.4999999 and so on. So I'll just round it off to 0.5. So if I sum the two, which is now like 66x plus 0.5, it must give me the final answer of 33.5. Okay. Then move this 0.5 that side to be a subtraction. So 66x is equal to 33. Then divide both sides by 66. That cancels that. So 33 over 66 gives me a half. So our x is a half of 0.5. Okay, so that is question number 2. Let's look at question 3. Question 3. All right, question number 3 of this worksheet. They're telling us that in a quadratic sequence, we have the following properties. The second difference is a 10. Okay. The first two terms are the same. Okay. And then T1, T2, and T3 are basically 28. Now, what we can see is that for as long as the first terms are the same, simply means that the first difference, the first term of the first difference is 0. Okay. I don't care what this one will be, maybe a y. Okay, y minus x. The second difference is a 10. So we can get a general term as per what they want us to get. But before we get there, do we need to find the T3? Yeah, I think we can find the T3 this way. It's possible because they told us T1 and T2 will be the same. But we don't know what T1 and T2 are. Okay. Let's see, we shall see. But for as long as we have this, then we can probably play around with something because we have this, we have that. Our problem is that x. Okay, let's see. What are we going to do? X and the y. Okay, I'm just taking y to be my third term. Okay, so this is question number 3. So I said x and y. That's gonna be a 0. That's gonna be y minus x. That is a 10. All right. So they told us T1, T2, T3 must be 28. Ne? So which means 2x plus y should give us a 28. But we know that y minus x minus 0 should give us a 10. Okay. So what is my point? My point is I want x. I don't need y. Okay, so let me substitute. So y is going to be 10 plus x from this equation. Okay, then I'll get this and then replace it. Wow, so that I get my value of x. So which means it's 2x plus 10 plus x should give us 28. Is it going to make sense? I don't know. Okay, so 3x is equal to 18, which means x is a 6. Okay, so I think we have everything that we needed. So that's a 2a, 3a plus b, that is a plus b plus c. Okay, so if 2a is 10, which means a is a 5. Then if 3a plus a b is a 0, we know that term a is 5, so that's going to be 15. Take that side, which is negative 15. Then a plus b plus c should give us a 6 as our first term. A is 5, b is negative 15. We're looking for c, so that we get a 6. On the left, we have a negative 10 plus c is a 6. Then c becomes a 16. I don't know. Let's just finish up. So 5n squared. Okay. This is 5n. And then we say minus 15n plus 16. Is that what the question has? 5n minus 15 plus 16. Perfect. Okay, so we've just proved what the question wanted. And then 3.2, is 216 a term in the sequence? Okay, just by your answer with necessary calculations. Now, for us to prove whether a number is a term, we can try to find the position of that number in that particular sequence. Now, if ever we get a negative, this is a negative position or a decimal position, then that won't be a term. Okay, so where there is tn, let's put 216. Okay, so 5n squared minus 15n plus 16 should be equated to 216. Let's move it that side. 5n squared minus 15n, when it moves, we shall have a negative 200. Divide through by 5, n squared minus 3n minus, is it 40? Looks like, okay, minus 40. Then I can use my factors. That will be 8 and 5, okay, n and 8, n and 5. So since I'm talking about a negative and a positive, I'll have this. So it's either n is going to be 8 or n is going to be negative 5. But what we know is that position can never be negative, okay? So which means we shall take this 8th position and draw a conclusion that therefore 216 is the 8th term, okay? So it's the 8th term of the sequence. All right, so that is what we had to do in that case, worksheet number 2. All right, we have worksheet number 3. Worksheet number 3, there we go. So feel free to pause, attempt, and then we proceed. Okay. Question 2 for worksheet number 3. Worksheet number 3. Okay, so question 2. They're telling us that given the arithmetic 7, 12, 17, so we can see that they are basically adding the 5. They want us to get the T91. So for us to get T91, we need to first of all get the nth term, which is 8 plus n minus 1 into d. So A is a 7. Remember we're looking for T91. So 91 minus 1, which is going to be 90, multiplied by 5. Okay, so that is 90 times 5 plus 7, which is going to be 457. Okay, then they want us to get the S of 91, the sum of the first 91 terms. So from the formula, n over 2, do we need to, it's 2 marks, ne? Can use A plus L straight away. Okay, because L is the last term, which is 91. So I can get that. So we have 91 over 2 into 7 plus 457. Let's put this in the brackets, 457. Okay. Divided by 2 times 91. So I'm getting 2, 1, 1, 1, and 2. So that is the sum. So this is the quickest name. But you can still use that other method. You still end up with the same answer. And then determine the value of n for which Tn is 517. Where there is Tn, let's put 517, okay? So we're saying 517 is equal to, remember we said n minus 1 into d. 7 into n minus 1 into 5. So let's move the 7 that side. Subtractions will be 510 is equal to n minus 1 into 5. Divide both sides by 5. So 510 divided by 5, which is 102, is equal to n minus 1, which means our position is 103. Okay, so we're done with these ones. Then 2.2. 2.2. The following information is given about a quadratic pattern. Okay. T1 is 3. T2 minus T1 is a 9. T3 minus T2 is 21. Can we show that T5 is 111? Okay, so we have a 3. Okay. And then we have T2. And then we have T3. Telling us that the difference is a 9. And then the difference here is a 21. Okay. So it's a quadratic that we know, okay? So which means our second difference is going to be 21 minus 9, which should give us a 12. So we know that 3 plus 9 is going to be a 12. 12 and 21, that's going to be a 33. Plus 12, which is going to be a 33. And 33 plus 33, we're going to end up with a 66. You plus 12 here, we're going to have a 45. And then 66 plus 45, you'll have your 111. All right, so that is how we would have shown that, okay? Then can we show that the general term is given as that? So we should be in position to get this answer. Okay, you can just see that your A is a 6. So 2A is a 12, which means A is a 6, okay? And then the 3A plus B should be equated to 9. If A is a 6, that's going to be 18 subtracted from 9, which is negative 9, which is that. And then A plus B plus C should be equated to 3. Now, if your A is a 6, your B is a negative 9. Okay, that's going to be negative 3. You move the 3 that side, you get a positive 6. So that is how we will be able to show that. Then 2.2.3, can we show that the pattern is increasing for all? So that is how we would have showed that the nth term is given us this, okay? Then can we show that the pattern is increasing for all natural numbers, okay? So we know that natural numbers are just the counting numbers from 1, 2, 3, and so on and so forth. This pattern is quadratic, which means it's a parabola, okay? So remember, if I have this dotted line here, on the left-hand side of the dotted line, we can see that the graph is decreasing, okay? And then on the right-hand side, the graph is strictly increasing. So if only we can find the axis of symmetry, then we know that since our A is greater than 0, okay, the graph is going to have a minimum at this value, okay? And then on the right-hand side, we need to see, okay? So if this value is any number that is not this, then this statement is valid, okay? If it's any number that is outside of the natural numbers, then it has to be valid, okay? So I'll say my x or my n is gonna be negative b over 2a. So b was a 9, so negative 9 over 2 times 6. And then we're getting 3/4 or 0.75. Good. So since we are getting 0.5 as the minimum point, okay, so we can say that the pattern is having its minimum as 0.75. which means the graph will just increase, okay, for all natural numbers to n, for all numbers that are natural in the positions, okay? So if n is 1, we're going to get a positive answer, regardless of which answer we get, but it has to be positive. And then if n is 2, n is 3, and so on and so forth. Alternatively, get this, and then substitute it into this expression and get your maximum or your minimum value, and then you take it from there. Then question number 3, given the geometric series 3, 6, 12, and so on, they want us to write down the general term. Okay, so we know that the general term is AR to the exponent of n minus 1. Your A is a 3. What's your R? 6 divided by 3, that's going to be a 2. N minus 1. That's what the question wanted, okay? Then 3.1.2, calculate the value of k such that the sum of everything here is equivalent to that. Let me jot it this side. This is 3.1.2. So they said summation of p is equal to 1 up to k, and then 3 over 2 into 2 to the exponent of p, okay? It's equivalent to 98,301. All right, so what we need to know, we need to find, is it a geometric or is arithmetic? Let's not take chances. So if p is 1, that's going to be 3. And then if p is a 2, that's going to be 4, 2, 6. Is it not the same? It's the same thing. Okay, it's the same thing. Okay, so which means we can try, that's going to be 12. So which means our common ratio is going to be a 2. Our first term is that. But we need the number of terms, okay? So how many marks is it? It's 4 marks. So we know that the number of terms will be k minus 1 plus 1, which is basically k terms. So the sum of the geometric is given as a into the r is bigger, so I'll use Rn minus 1 over r minus 1. Answer equated to 98,301. Let's do the substitution, okay? So our a was a 3 into 2 to the exponent of k minus 1 over 2 minus 1 is equal to 98,301. All right, so 2 minus 1 is a 1. So we're just going to divide both sides by 3. So that's going to be 98,301 divided by 3, which gives me 32767 is equal to 2 to the exponent of k minus 1. Let's move the one that side. 2 to the k, it's going to be 32768. Then all I need to do, I can use log, so I can express this in exponential form with a base of 2. Okay, so 32,768. Okay, I'll press my equal sign, then I'll press shift, and then the factorization button. Okay, so 2 to the k is equal to 2 to the 15. Okay, so which means k is 15. All right, so that is how we would have obtained that. Then 3.2, there's a geometric and arithmetic that have the same first term. The common ratio of the geometric is 1 over 3. The common difference is just a 3. This is a d. The sum of 22 terms of the arithmetic is this, more than the sum to infinity of the geometric. Determine the first term. Let's see. We talked about the sum of the 22 terms of the arithmetic. So I'll say the sum of the 22 terms is 734. plus, okay, it's more, 734 more than the sum to infinity. Then what do we need? What do we need? They want the value of the first term. But we know that sum to infinity is a over 1 minus r. We know the common ratio, yes. We don't know the first term. But we also know that sum of the first 22 is going to be 22 over 2 into a, it's twice a, plus n minus 1 into d. That's going to be 22 minus 1 multiplied by the common difference, which is a 3. Okay, let's see how this is going to come out. So I have 22 over 2 into twice a plus 22 minus 1, which is a 21, multiplied by 3. This should be equated to 784. Is it 784? It's 734. Okay, so it's a 734 plus the sum to infinity, which is a over 1 minus that. Okay, so that's 11 into 2a plus 63 is equal to 734 plus a over 2/3. This becomes a 22a plus 63 times 11. I get 693 is equal to 734 plus I can have 3 over 2a. Just flip it around. Okay, let's move this that side. We move it this one that side. So 22 minus that I'm having 20,5a. 734 minus the 693. I'll get a 41. Okay, we divide by 20,5 over 20,5. Okay. This must give us 2. So the first term is just a 2. Okay. Let's look at worksheet 4. So we said get the sum of the first 22, which is this format, sum to infinity, and then express that format. And then that is what we just went through, okay? Do the substitution, collect the like terms, and then our answer should be a 2. All right, worksheet number 4, that's question number 2. All right, so 2.1.1, given the following geometric, they want us to determine the common ratio in terms of x. So remember, I can use T3 over T2 if I'm scared of this fraction. So I'll have 6x over 12, which is basically a half of x, or which is also the same as maybe x over 2. There's no problem. There is no problem. Then determine the values of x for which the series will converge. So for convergency, excuse me. Okay, so we say this is worksheet 4. So for convergence, we say -1 is less r is less, then substitute r with x over 2, multiply through by 2. So -2 is less x is less 2. And then that becomes our answer. And then if x is a 4, they want us to get the sum to the 15 terms. So this is a geometric, okay? So S of 15 terms will be a into 1 minus r to the n, which is going to be 15 over 1 minus r. Our first term was 24 over 4 now, which is going to be a 6. Okay, so that's going to be a 6 into 1 minus. This is going to be a half to the exponent of 15 over 1 minus a half. Just punch this into your calculator. So 6 into 1 minus a half to the 15. And then over just a half. This gives me 11,999,633. But they told us we must always round off to decimals. So this is approximately 12. Okay, so that becomes 2.1.3. And then 2.2. Calculate, okay, sigma notation, n1 up to infinity of this. Let me jot it aside because this question is interesting. Say n is equal to 1 up to infinity. Then we have 6 into 2 to the negative n. Is that correct? Perfect. Okay. So they want the sum to infinity, but we need to determine our a, we need to determine our r. These are the key variables that we need. Replace n with a 1. Okay. Our a becomes a 3. Then if you replace n with a 2, if n is a 2, you're gonna get 3 over 2. And so on and so forth. So my common ratio is gonna be 3 over 2 divided by that. So it means my common ratio is a half. I hope what I'm saying makes sense. Yeah, it's a half. So if that is correct, then I'll just go down and say sum to infinity is a over 1 minus r. So a is a 3 over 1 minus a half, which is gonna be just a 6. So that's the sum to infinity. And then the sum. I love this question. The sum of the first n terms of an arithmetic will be given as this. Calculate the sum of the first 15. So where there is n, just replace it with the 15. So negative 15 squared plus 8 times 15. Okay, so that's going to be negative 225 plus 8 times 15, which is negative 105. That's what I'm getting. Then calculate the value of T15. Now, what we need to know is that this is 2.3.2. What we need to know is that if we have the formula of the sum, okay, which is given as what? Negative n squared plus 8n. For me to get the terms themselves, I'll need to use the consecutive sums, okay? So in other words, we know that S1 is the same as T1. And then if I get the sum of the first 2 terms minus the sum of the first term, I should be able to get T2. And then T3 must be the sum of the 3 terms minus the sum of the first 2 terms. Okay. Now, since they're asking for T15, I'll have to get S of 15 minus S of 14. Okay. So we have already obtained our S15 as negative 105. What we need is the S of 14. Okay. Negative 105 minus, say, negative 14 squared plus 8 times 14. right, so I'll punch this into our calculator. So 14 squared is 196. Which is negative 84. Okay, so punching that, I'll have negative 105 plus 84, which means my T15 is negative 21. Then if the first term is a 7, which term will have a value of negative 169? Okay. So we're saying the first term is a 7. But we know that which term will have a value. We need to find the first difference. This is the only key thing that we need. We have the a's as a 7. We need the first difference before we can get the n of this. So we shall still do the basics, okay? Let's get the S1. Just replace n with the 1. N with the 1, that's going to be negative 1 plus 8, which is a 7. Oh, they already told us that. Shame. Let's get S2. S2 is going to be negative 4 plus 16, which is 12. S2 is a 12. Then if S2 is a 12, something is off. Shall fix that. If S2 is a 12, which means we have S2 is a 12, so which means our T2 must be S2 minus S1, which means if our S2 is a 12 minus the first term is a 7, which means our T2 is a 5. So we have first term as a 7, second term as a 5, which means the common difference is a minus 2. Then they're asking for T what? We're asking for n, where Tn is negative 169. Okay. So it's going to be negative 169 is equal to 7 plus n minus 1 into negative 2. Let's move the 7 that side. That gives us 176 negative. Let's open that up, negative 2n plus 2. Let's move the 2 that side, which is negative 178. It's negative 2, and divide both sides by negative 2. And then now n becomes positive what? 8 what? Saying 178 divided by 2. That gives me 89, okay? So the 89th term will have that value. All right, so that is question number 2. Question number 3. Question number 3. Consider the following quadratic. Determine the value of y. Okay, so just follow the basics of getting the differences and then equate the second differences. You should be able to get y as a 51, just the way they're telling us here, that y is a 51. Then they want us to get the general term that we've done several times. Just do your 2a, 3a plus b, and the c, and so on and so forth. Then determine 22, where there is n, we're going to replace it with a 22. And then which term will have a value of this? So this is your Tn equated to the quadratic. Okay, let's see. Let's not just talk. So 95, that's going to be 72 minus 95, which is negative 23. This is a y minus 72. And then this is going to be a 32 minus y. Then down here, it's going to be negative 72 plus 23, which is negative 49. Okay, so y minus 49. And then here, so this minus that. So 32 plus 7, 2 gives us 104 minus 2y. And then I'll equate those two. Okay. So we're saying y minus 49 is equal to 104 minus 2y. Let's move it that side. It's a 3y. Then 104 plus 49, which gives me 153. Divide both sides by 3. And then y becomes a 51. Then for the Tn, we said it's going to be our 2a. So that's 51 minus 49, which is going to be a 2. Okay. 2a is a 2, which means a is 1. 3a plus b must give us this negative 23. But if a is 1, which means b is going to be negative 26. A plus b plus c must give us a 95. Okay, our a is a 1 minus 26 plus c is 95. So 95 plus 26 is 121 minus 1, which means c is going to be 120. So just to rewrite the Tn, it's going to be n squared minus 26n plus 120. And then we say that for us to get the T22, where there is n, we're just going to put a 22. So 22 squared minus 26 into 22 plus 120. It's just one mark. 22 squared minus 26 into 22 plus 120, which gives us a 32. Because it is reducing. Why are we having this? Yet we also have that. Yes, this is a parabola. It's possible. Then which term will be equivalent to 1040? 1040, 1040. Let's see. So we said 1040 should be equivalent to n squared minus 22n plus 120. So n squared minus 22n. What's 120 minus 1040? That's 920 is equal to 0. Then all we have to do is solve this quadratically. So you can use your quadratic formula, or alternatively, you can use the vectors. Okay, so if I use my vectors, whatever I'm getting is not making sense. Whatever I'm getting is not making sense. Let me just go back and review my answers. So this is a 26, not a 22. Okay. So if it's a 26, which means we're going to have n with a 20, and then n with a 46, minus and plus is equal to 0. So n is either negative 20 or n is a 46. But since we want position, we shall take the positive position. With the previous question, let's hope I did the correct thing, correct substitution there. All right, so that is question number 3. Worksheet 5, which is the last one. So you can attempt this, and then we can go on and look at it later. Okay. So they're telling us that the first term of an arithmetic is 7. Okay, so saying A is a 7, the common difference is a 5, and the series is having 20 terms. Now they want the sum. So S of 20 will be 20 over 2 into 2 times the A, which is a 7, plus 20 minus 1, which is 19, multiplied by 5. So just punch that into your calculator. Okay, so we say 20 over 2. Open brackets, we have, that's a 14. What's happening? What is happening? 14 plus 19 times 5. So that gives us 1090. Okay, then 2.1.2, the original arithmetic is extended up to 75 terms. And then the sum of these 75 terms is 14,400. Using the sigma notation, you can write an equation for the sum of the terms added to the original. Okay, so we know that originally we had 20 terms now. Then if we have 75 minus 20, that's going to be 55 terms now. So if we start from 55, 21 plus 1, we're going to be talking about, wait a minute, we're talking about how many terms? We have 75 terms altogether, okay? Originally, we had 20 terms. Now the question is, how many terms are we going to be looking at? Someone told me 55 terms that we shall be considering. Is it going to make sense? So which means we're looking at 55 terms. Yeah? So the starting limit will be n is 21, the 21st term, and then we shall end at the 75th term. All right, what do we know? What else do we know? We know that the first 20 terms are 1090. We just need to subtract this. All right, so it is 14,400. Okay, so 14,400 minus 1090. So punching that into our calculator, we shall get 13310. Okay, so sigma notation, we're saying n is 21 up to n is 75. What is the general term? Remember, it's arithmetic, so it's 7 plus n minus 1 into a 5. So it is going to be like 5n plus a 2. That's what I'm getting. Okay, so I'll put the 5n plus 2 here, and then I'll equate this to 13310. So this is all they wanted us to write or express. Okay. Then the next question, 2.2. The sequence of the first difference of the quadratic is 1, 3, 5, and so on. If T99 of the quadratic is this, can we calculate T98 for 3 marks? Okay. First differences are 1, 3, and 5. So which means we're gonna have the second difference of just 2. Now they're telling us that the 99th term is 963, somewhere here. What about the 98th term? So if I'm to follow the first differences, so the first difference between 98 and 99, T98 and T99, is going to be the 98th term of the first differences, okay? So which means if I can find T98 of the first differences, so T98 of the first differences, then I'll just do the addition or subtraction from what they gave me, and then I'll have my answer. So if I have 1, 3, and then 5, we say this is a 2. So which means our nth term is just going to be 2n minus 1. If you simplify that further. Then I'm looking for T98. It's going to be 2 times 98 minus 1. Okay, so 2 times 98 minus 1 gives me 195, which is a positive, okay? Then we've been given the 99, that's 9632. So T9 is 9632. This is for the quadratic. So for me to get T98, it's going to be 9632 minus 195, since I'm moving backwards. So 9632, I'm subtracting 195. That's going to give me 9437. Okay, so that is what I'm getting. Then 2.2.2, if it's further given that the third term of the quadratic is 32, can we determine the general term? They want us to determine the general term. Okay, so we have 1, 3, and 5. So what we're gonna do is let's see. 135, 135, 135, 135. Okay. So we said 1, 3, and 5. Okay, then they told us, they gave us the 2, the third term. Okay, third term is a 32. Okay, so if this is a 32, so 32 minus 5 is gonna be 27. Does this make sense though? 1. Okay, let me just get it in a different format. So we're saying this is a 1, this is a 3, that's a 5. This is 32. Okay, 32 minus 3 is going to be a 29. 29 minus 1, that's a 28. That's a 2 across. Okay. So we say 2a is equal to 2, a is a 1. 3a plus b is a 1. B is going to be negative 2. A plus b plus c is going to be a 28. That's going to be negative 1, which means c is going to be a 29. So which means tn is going to be n squared minus 2n plus a 29. All right, then lastly, question number 3. Question number 3. They're telling us that a circle with the radius 6 is drawn. Then a second circle is drawn through the center of the first, which touches the first, internally as shown. That circle, the story continues, and then it forms a geometric pattern. What is the radius of the third circle? So if the first radius is a 6, okay, remember from the center, this is a 6, that will be a 6. Then the radius of the second circle is going to be a 3. Okay, and then the radius of the next one is going to be 3/2, and so on and so forth. Okay, now 3 divided by 6 is a half, so you're just multiplying by a half. So this is going to be 3/2 centimeters, or you can just write it as 1,5 centimeters. Then 3.2, calculate the sum of the areas of the first 10 circles. Now they're not asking for the sum of the radii, okay? They're asking for the areas. Now, how do we write the area of a circle? We know that area of a circle is given as pi radius squared. Now, let me try to write down the areas of the 3 circles and see what sort of pattern I'll have. So the first circle, I'll have 6 squared, which is 36 pi. With the second circle, I'll have 3 squared, which is going to be a 9 pi, and so on and so forth. So it's still forming a geometric. So my common ratio, okay, the common ratio is 9 pi over, I'll just say 9 over 36, which becomes a quarter. Okay, then the sum of the areas, remember the formula for the sum of the geometric is A into 1 minus Rn over 1 minus R. So our first area is 36 pi into 1 minus the R, which is a quarter, to the exponent of 10 over 1 minus a quarter. And I punch this into the calculator. So 36 into 1 minus . Okay, so I'm getting 47,999. So continue. So which means it's approximately. But let me just multiply it by the pi before I round off, okay? So this answer multiplied by the pi, which gives me 150,796, which is more or less 80 centimeters squared. All right, then 3.3, which circle has a diameter of 3 over 128. Now the question was talking about radius. Now they're switching into diameter. It's okay, no problem. So we know that diameter is basically half of the circle, okay? No, diameter is the total distance across the circle. Radius is the half of the circle. So radius is gonna be 3 over 128. I'm gonna divide that by 2. So 3 over 128. We say divided this by 2, we're getting 3 over 256. Then the general term, remember we say the original was a 6 into AR to the n minus 1. Then we have the ratio, which is a 2. Is it a 2 or half? 3 over, it's a half, to the exponent of n minus 1. Now, where there is Tn, I'm going to put 3 over 256 is equal to 6 into a half to the n minus 1. So let's divide both sides by 6. Okay. So divide by 6, I'm getting 1 over 512 is equal to a half to the exponent of n minus 1. And then when I express this answer of mine as an exponent, it's going to give me a half to the exponent of 9 is equal to a half to the exponent of n minus 1. Eliminate the bases so that 9 is equal to n minus 1, which means n is going to be 10. So the 10th circle will have a diameter of 3 over 128. All right, guys, so that is that. And I will stop there with the discussion. Please feel free to slot in your comments where we differ. Feel free to do the correction there. But that's more like a rough sketch of what exactly needs to be done. Thank you very much and all the best.